Hypothesis testing. A hypothesis is a proposed answer to a research question based on limited evidence. Hence, data has to be collected in order to test its veracity or truthfulness. There are different approaches to different hypothesis tests. And you have the critical value approach or the classical approach, and you have the p-value approach. The classical approach, in this approach, you have to compare test statistics calculated using sample data with a critical value on a distribution curve. So the critical value approach, you're comparing a test statistic to a critical value on a curve. The p-value approach now, you can do it manually or you can use any other software like Excel, Minitab, etc. In this approach, you have to use a test statistic calculated from a sample data to obtain a p-value, and that's a probability value determined by sample data from a statistical tables or software to compare with a significance level called alpha, and that's a probability value determined by established research. So with the p-value approach, you have to compare p-value, a probability value, with a significance level. Okay, so now the two differences. The critical value approach, a test statistic is compared to a critical value, and the p-value approach, a p-value is compared to a significance level. So the p-value approach using Excel or any other software. First, you identify the appropriate hypothesis test. You know, it could be a z-test, it could be a t-test, or no, for mean. Translate the worded hypothesis to mathematical form. Then state a pair of hypotheses and establish a probability value called the significance level, called alpha. All right, you can use 0.01, 0.025, but 0.05 is very commonly used. Okay, so the step one, you have to state a pair of hypotheses, and for the z-test and the t-test, you have to state it in, translate it to symbolic form. Okay, the pair of hypotheses. One call is HO and the other one call is HA, or H1, the null and the alternative. So that is step one, a pair of hypotheses, the null and the alternative, HO or HA, or you can call it H0 and H1. Step two, you have to input the data in Excel or any other software that you are using. So the data, you have to input it in the statistical software. Step three, you have to process the data in the statistical software that you use. It could be Excel or SPSS, so then you process the data. Step four, you have to identify the p-value from the output that the software provides. So after you process the data, the software have to give you an output, either Excel or Minitab or SPSS, and you have to identify the p-value in that output. Step five, you compare this p-value now to the significance level alpha. You know, you can use 0.05. So this p-value, that probability value that the output give you, you compare it to alpha, you compare it to 0.05 if that's what you are using. Now, step six, now you have a decision to make, okay? Either you reject the null if the p-value is less than the significance level, 0.05. So if that p-value identified is less than 0.05, you reject the null. And you do not reject the null if the p-value is greater than the significance level. So there are two types of errors that can be made. A type 1 error occurs if the null hypothesis is rejected and it is true. And a type 2 error occurs if the null hypothesis is not rejected and it is false. Step number 7, you have to conclude. So now, if the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null statement itself is the conclusion. And always remember that you will start the test with two statements, the null and the alternative, HO and HE, or H0 and H1. After the test is done, only one will be the conclusion, either the null or the alternative. Either one of them will be the conclusion. So there are different hypothesis tests that can be done. As you can see, this is a diagram showing most of all the hypothesis tests that exist. You have the one samples and you have the two samples. You have the parametric and you have the non-parametrics. And we are going to focus on the two samples t-test. We're going to use it as an example. You have the z-test, you have the t-square, you have a lot of different tests. We're going to focus on the two sample t-test. So for the two sample t-test, for step one, you must identify a pair of hypotheses. So these are the three scenarios that you may be confronted with a t-test, two sample t-test. So the HO can be the mean, group A is equal to B, and the mean of group A is not equal. So that is scenario one. Bear in mind, that's the pair of hypotheses. For the two samples, you're comparing the mean value of two different samples, two independent samples. So it could be your scenario 1. You could start your test with scenario 1. Scenario 2, here, and remember the worded statement have to be in symbolic form. So here's the statement in words, the H1 in words, and here it is in symbolic form. Scenario 2, the mean of A is equal to the mean of B, and the mean of A is less than the mean of B. And here you have it in symbolic form. And scenario 3 could be the mean of A is equal to the mean of B, and the mean of A is more than the mean of B. So either 1, 2, or 3, that's how you can begin a two-group t-test. So here is an example we're going to use. We have two groups, Group A and Group B. So these are the scores of Group A and Group B. So the data has been inputted into Excel already. And here you have a setup already. So the statement, here they are, HO and HA. The mean scores of Group A is equal to that of Group B. And here you have it in symbolic form. And H1 is saying, or the alternative statement, the mean scores of Group A is less than that of Group B. And here you have it in symbolic form. So that's our step 1. Now we have a decision to make, but you know we have to process the data in Excel and then for us to look for the output. So in order for us to make the decision, all right, bear in mind we have to reject HO, all right, if the calculated probability value is less than the significance level. And if it is greater than, we do not reject HO, okay, bear that in mind. All right, and here you have the rejection if it's a critical value approach, but it's a p-value approach we're using, so we're going to focus on this decision. Either we reject HO or we do not reject HO based on the p-value compared to 0.05. So to get that p-value, what you need to go is to go into data analysis, make sure data analysis is added to your Excel, and you go down, scroll down, and you look for, here it is. You have t-test, 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 and z-test. So we want the t-test for two samples. All right, two samples. We can use two samples assuming unequal variances. So we can use that type of two samples. Or we don't know the variance. We just put the data there, so we can assume that the variances are unequal, and we can use the two samples, not the paired, the two samples independent. Click OK, and the variable 1, the range for it is from, so if we want the labels, then we can start with the scores, and then that's variable 1 from A1 to A8, and variable 2 from B1 to B8. Okay, now since we would like the labels to be shown, we click on labels. If we started on A2, then we would not have to click labels. And then the alpha, look, the alpha, the 0.05 that we talked about, the significance level, here it is, because we have to compare the p-value to this alpha, and we stay. If you want, you could have used 0.01, you could have used 0.025, but let's use 0.05. And actually, you can see it came as default because it's very commonly used. So we need to get the p-value to compare to the significance level to decide whether to reject or not to reject HO. Okay, HO is saying that the means are equal to, mean of A is equal to the mean of B. So you click OK. And here the output is given in a separate spreadsheet. Okay. So we need to identify the p-value. Now, you have the different p-values here. You have p-value for a one tail, that's towards the left, a one tail, and you have a p-value for two tail. Okay, so the p-value for the two tail is if we are equal and not equal. If that was what that was our pair of hypothesis, but we choose. We said that the mean of A is less than the mean of B, so that's a one tail. So the p-value is 0.01687. Let's make a note of that. Okay, so that's the p-value. Okay. So we can make a note, 0.01687. So that's the p-value. So our decision, okay, so since, as you can see, 0.0167, 0.0168687 is less than 0.05, okay? So since the p-value okay, so that's the different hypothesis test. Since the p-value, and we can round it off of 0.017 here, is less than the significance level. Here it is, of 0.05. All right. We have to reject HO, okay? Reject statement 0, reject HO. We reject the null, okay? Because our p-value is less than the significance level. And since we reject HO for conclusion, if HO is rejected, then the alternative is the conclusion, okay? It says here, conclude with H1, that's the alternative if HO is rejected. So therefore, this statement there is our conclusion. So we can just copy it as our conclusion. Bear in mind, we always start with two statements and one is the conclusion. In that case, each one is the conclusion. The alternative is the conclusion because we rejected HO. The mean scores of group A is less than that of group B, or you can even say significantly less. Okay, and you can actually see it. The mean score, here's the mean score of group A is 65. And the mean score of group B is 88. So you can actually see it that the mean score of group A is less than that, is significantly less than that of group B. And the test actually confirms that suspicion, okay? Because here we rejected HO because our significance level of 0.017, here it is, 0.0168, 0.17 is less than the significance level of 0.05. So therefore, since we reject HO, we conclude with H1. We conclude with the alternative because we rejected HO. All right, we put an X on HO, so H1 is our conclusion. And we stated here the mean scores of group A is significantly less than that of group B. So you can try this out now for this example here, okay, with the scores of C and the scores of D.